Redux Saga with TypeScript. We are going to make a to-do application using Redux Saga and a API I wrote myself. We are going to use a starter project. You can get this starter project in the link below. If you switch to the starter project branch, this contains all the starter code we are going to use in this project. I'm going to use my own API for this to-do, which I've written in Express. You can get the code for that API in the description below. The repository has all the instruction on how to install it and how to run the server and all the endpoints it has. For example, to get all to-dos, you can use this endpoint. The package.json of this project has already some dependencies, but we are going to do all the Redux Saga installations from the scratch. So I'm going to use yarn for installation, but you can use npm as well. So the command is yarn add Redux Saga. Once this is installed, we're going to apply the middleware in our index.tsx. As you know, Redux Saga is a Redux middleware, so we have to apply it in our apply middleware function. Let's import it. Now we have to run the function. And we can pass this middleware in the apply middleware call. We have to put this below the import statement. And then we have to call a Saga middleware. You have to pass a Saga inside here. I'll tell you what that is in a second. I will comment this quickly and show you how the application looks currently without any Redux Saga functionality. Similar to our React Redux TypeScript tutorial project, where we made a to-do application which used Redux. We are going to use an API to store all our to-dos and use Redux Saga to make those API calls. As you can see, this doesn't work at all right now. Let's create a Saga. I'm going to make a folder called Sagas. Inside it, I'm going to have a to-do Saga. Here I'm going to import some effects from Redux Saga. So what we're going to need is take every, put, and call. Now there are two parts to Redux Saga. There are watchers and workers. So currently our application has some action creators installed. If you don't know how to do this, I highly recommend watching my React Redux TypeScript tutorial. I'll link it in the I button and the description below. So in our app, when I click buttons and when I add a to-do, these action creators are called. And what these action creators do is dispatch these actions. For example, if you want to mark a to-do as complete, you just send in an ID with mark complete type action. So what we do in Redux Saga is we define a function with this syntax. This is not a normal JavaScript function, but it is a generator function, and we're going to name it to-do Saga. What this generator function does is that it allows us to have breakpoints in our code. So for example, if I yield take every, what this does is that it will catch all the actions that have been dispatched. For example, if I have an action called make mark completed, then I can catch that action, can stop that dispatch and create a new dispatch. So how we can use this is like when the React UI tells us to mark a to-do as complete. We catch that action and we make a API request from Saga itself. And after we get that response back that our to-do is added, then we can update our Redux store. So in this case, we are going to take every mark complete action which is dispatched and call our own function called create to do worker. I'm going to define this function later in the worker section. Define it same as we defined the watcher. There is a generator function as well. So create to do worker. So now what we are doing here is we are looking for mark complete action and we are calling our own worker on this. We stop that action there itself and we call our new function. Now in our types folder in action types, I have these action defined here in an object. I'm going to import this in our Todo Saga so that I don't have to type the action every time. Let's import it. And I specifically want action IDs like that. And then instead of typing in a string, I can use this object. So mark complete. Or in this case, as this is a to create work, I'm going to use create to do. So I'm going to look for create to do action. Let's make more action creators the same for different actions. So I have delete to do, and I'm going to define workers for them as well. Now I have all these workers defined. Now in this workers, we do our actual API request or any other asynchronous code. So for example, when create to do worker is called, I'm going to create a to do using API, and once we get the response, we are going to update our Redux store by dispatching a new action. So these are the two main things we do in this worker. Now I'm going to add a proxy to our package.json. What this proxy does is when I make an API request to, for example, API/v1/todo, if I make an API request to that, our React server would not have that endpoint set. So what it would do is it would redirect us to our proxy server. For the purpose of this tutorial, I'm going to use my hosted API. So this is my hosted API for this project. You can use your local installation as well, as I showed you before from the To-Do API repository. Now I'm going to quickly set up my API, my Axios API. I'm going to import Axios. I'm not going to explain this part of the code because it is not part of Redux Saga. We're going to create a variable. We're going to pass some configuration here. So I want the base URL to be /API/v1. I'm going to export. From this file. Now to add type safety to our code, I'm going to use a generator, which is an inbuilt type, and we're going to set the yield type. So whatever this function would yield to a specific type from our Redux Saga. It is called strict effect. So the type safety it adds here is that we can't yield anything other than a Redux Saga effect. Now let's import our configured Axios API. Import Todo API from API/Todo API. So if you have used Axios API before, you would know that the way to make a GET request is by doing todo api.get and then pass URL. So in this case, it would be todo, and then you can pass any configuration if you want. And whatever this returns a promise, and if you then execute the promise, then you would get the response. So if you look at the API documentation for get route, you have to call API v1 todo, and if the response code is 200, you would get this kind of data. And if there is no todo inside a database, then we would get a 204 and a 500 for error. So inside the workers, we're going to call our API. We can't just run our function directly in our worker. Instead, we have to yield what we want to run to the Saga. What yielding does is that it tells Saga to do something. So in this case, I want Saga to call a function. The function is called todo api.get. And what parameters I want to give it? The second parameter to this call function are all the parameters I want to put in that get request. So in this case, I want to pass the URL, which is /todo. I'm only appending todo as we have already configured our API in todo API. So API/v1 is already configured. I just have to add whatever extra I need in that URL. So this is how you would call a API, and then we can store the response in a variable like this. Now if we look at this response, it is of type any. So TypeScript doesn't know what we are going to get after this yield is finished. So we have to tell that this is going to be Axios response, and we have imported it from Axios. Now if we get a 200, then it's fine, but what if we get an error? That's why we have to add a try and catch block like this. And so when we get a 200, we would stay in the try block, and if we get an error like 500 status code, then we would go to the error block. And now from here, we can dispatch new actions to our reducer after this API request is complete. For example, when I add some to do, or when I get some to dos, I can append those to dos. I can ask the reducer, I can dispatch a new action to add those to dos to our Redux store. And if I get an error, I can show a notification by dispatching a new action. Maybe it is called notification or error notification, something like that. So you can simply dispatch new actions here. The way to do that is by yielding put. So you can dispatch a new action here of type anything, you can call it anything, and we can attach some payload as well. Then you would have to configure your reducers to catch these actions and update the Redux store accordingly. So the put function is actually used to dispatch new actions from our Saga. I'm going to remove this for now, and now we can switch on response.status. So, and if the status code is 200, then I want to do something. The case the status code is 204, I would do something, and whatever else status code your API sends, you can perform actions according to it. In my case, I'm just going to care about the 200 code. I'm not doing any error handling. And here I would normally just dispatch a new action with some new type. This type should be different from our incoming types. So like create, you should not dispatch a create to do action again, because it would make you would start an infinite loop inside the Saga. So you have to dispatch a new action and catch it in your reducers to update your Redux store. Now to take advantage of using TypeScript, I will define these actions from advance. So in our action types, I'm going to define some more actions which are similar to these actions, but they are specifically emitted from the Saga. So I'm going to copy these actions. So I have these new actions defined here. These actions are a bit different from the actions which are components dispatch. So for example, our component dispatches get to-dos, and our Saga would dispatch got to-dos. So how this is different is that our app asks for some resource, and our Saga makes an API call and completes that task and then dispatches a new action. In my case, I have named it in such a way that it shows that the task is completed. The name of that action shows that the task is completed. So if you're not getting why I'm defining all these actions in a separate file and why I'm doing all these things, I highly recommend watching the React Redux TypeScript tutorial. I explain all this in detail there. Now I'm going to import those actions which we have defined. These are all the actions which are going to be dispatched from the Saga. Now if we look at this create to-do action, the definition of that create to-do action, you can see that it has a title property of string. So when we create a to-do from our UI, I'm going to send in a title using the action creator. So in the Saga, we can get access to this second property. We know the first property is the type property, but the second property is the title property. We need that title property in order to create our to-do using the API. So what Redux Saga does here is it passes these properties to our worker function as well. So if we look at data here, this data is going to have those properties. Redux Saga is going to pass those properties inside. But TypeScript has an error here. It doesn't know what data type this is. So what I'm going to do is I'm going to import create to-do action, because that is the action which is dispatched from the UI. I am going to say that this action is going to be of type create to-do action. Now you can see that I can destructure this into title and type. So I just need titles. I'm just going to destructure it to title. The very important thing here is that Saga passes in the properties of that action to a worker function inside this function argument, and we can define the type using the types we had defined inside this action type. So now let's look how to make an API call to create a to-do. So I have this API documentation open and I have to make a post request to this endpoint. So let's look at it. I have the endpoint set up, but I have to use a different method. I have to pass in the data as the third argument, like this. If you look at the documentation, it asks us to pass a title property which is of type string. Now once we have got the response and the response code is 200, we know that our to-do is created, and we can look at our response, how we are going to get it. So if the response code is 201, if the response code is 21, we are going to get this kind of data. So I'm going to change this to 201, and then I can dispatch a new action. So let's make that action first. Let's call it data. And now TypeScript is complaining again as it doesn't know the type of this. So I have defined these new actions. So for a Saga to use specifically, so if you look at it, it has, if you look at these ones, it has created to do. So The name of that action implies that the to-do is created and you want to add it to the Redux store. So I've imported them already. I'm going to set this to type created to-do action, and now I can get the autocomplete of type, which is going to be of created to-do, and data, or what is it, to-do of type, and I have to pass in the data I've got from the API. So it is going to be response.data dot to do, like that. And then I can dispatch this action by passing this data to output function, like this. So this is how we write a worker for our to-do Saga. I'm making the API request by using the yield command. I'm not using async await here because that is implemented in the Saga itself. When you're yielding this kind of call, Saga knows that it has to call to-do API post with these arguments. So it will do that for us and return the response. And then I'm switching on the response code, and then I'm going to dispatch a new action using the data I've got from that response, API response. And the benefit here is that we are defining all these actions in our action types, so we don't go wrong anywhere. I'm going to quickly just copy paste all the other workers, as most of the code is similar. You can check the code if you want more detail in the description below. I'm going to link the repository of completed code. So I have all these workers written already. It is similar to a create to do worker, but the API calls are different and we are dispatching different actions every time. For example, for deletion, we have deleted to do. So we have to write a reducer in such a way that it doesn't catch the actions from a component which is called delete to do or create to do, but it catches the action dispatched from our Saga, which are called created or deleted or whatever action you name it. So I've written up all the workers for this. Now for this watcher, we have to export this watcher from this file. I'm going to do that in the end of the file. Export default to do Saga, like that. So now that error is gone. Now we have to import this watcher inside our index wherever we are creating this middleware. So this is called to do Saga from saga/to do Saga, right? And we have to pass this in the run function here. We had commented this out, but we have to pass this here, like that. Next step is we are going to program our reducers to catch the actions dispatched from the Saga itself. If we look at a reducer, it is just returning an empty array. And let me show you how our store looks like. So I've defined a store in the types folder. So it has a key to do's and it is an array of to do. And how a to do looks like is to do is an object which has ID, title, and is completed. So all the properties we need for a to do. And currently our reducer is just returning an empty array. Now instead of coding this all, I'm just going to copy paste and explain it a bit, because I have already explained this in depth in my other series, and this video is not going to focus on how to write reducers in TypeScript. So if you want to learn that, check out that series. I'll link it in the I button in the description. So what we're doing here is we are catching all those actions dispatched from the Saga, like created to do, deleted to do, and we are updating the store accordingly. There's nothing much to talk here, except that if you want to understand this better and how to write this in TypeScript, I would highly recommend watching that series. To put a yield statement here. Now let's look at the application. I have my network tab and my Redux DevTool open. I'm going to refresh the application. And as the component renders, it makes a get request to get all the to-dos in our database. Currently, we don't have any to-dos in our database, therefore nothing is showing up here, but we are seeing a get to-dos action dispatched here. If I add a to-do here, I click add, as you can see, we are making a post request here, and a create to-do action is dispatched from the application. But after the Saga makes this Axios request, it dispatches created to-do action as well, and we update our state accordingly. So now we have a new to-do inside here. Now if I mark this as complete, we have a patch request. If I mark this as incomplete, we have another patch request. And if I delete it, we have a delete request. I'm using the actual hosted API for this. It is actually hosted on Heroku, but you can use a locally hosted version. You just have to change the proxy parameter in your package.json. Alright guys, this is all for the video. I will link the starter repository and the completed application in the description. I will also link the Todo API, which you can run, which you can use for your project to make API requests. And hope you liked the video. Subscribe for more such content. Comment down below what you would like me to make next, and see you guys in the next one.